Hi, welcome to SUSECON Digital 2022. I'm your host, Nuno Carmo, and this is my session about how to run Windows Server VMs on HarvesterHCI. So without further ado, let's start. In this session, we will first have a look on why we should use HarvesterHCI, a quick demo, and then how we can optimize our Windows VMs. Finally, there will be a conclusion. My name is Nuno Carmo. I work at SUSE Rancher as a tech writer. I'm also passionate about all technologies, and especially HCI. You can find me on internet on Twitter at NunixTech. So why Harvester HCI? Before we start, let's take out some few topics out of the way, if you please. First, the assumptions. If you know, or like me, have interest on HCIs or KubeVirt, then this is the right tool for you. Also, if you need to run at least one or several VMs on your infrastructure cluster, then again, this session will show you how. If you don't really care about Windows, but you still want to know what is Harvester HCI and how you can use it on your daily management, then this session can also help you. Now, what will be covered during this talk? First, we will have a demo of running Windows servers VMs on KubeVirt through HarvesterHCI. Then, we will try to understand what are the difficulties of doing such workflow by yourself and how Harvester can help us. Finally, we will just see how HarvesterHCI and KubeVirt together can really help us make operational maintenance a lot easier. However, some few topics will not be covered today, such as the KubeVirt installation by itself. We will use HarvesterHCI to use KubeVirt, so we will not cover the installation topic. The installation of HarvesterHCI itself, it should be covered in another session during SUSECON, so this one will not be covered neither. And also advanced feature gates like live migration. I put you the links in the slides, so at any time, please refer them if you want to deep dive into how to install or what is HarvesterHCI or KubeVirt. So, the technology stack that we will be using today is quite packed, but at the same time, they all work together. First, on the VM creation itself, we will be using Harvester to use it. I will show you the process on how to create a VM and then how easy it is to also start running it. We will really leverage the power of HarvesterHCI and will avoid any complexities that we might have whenever we want to run VMs on KubeVirt, for example. KubeVirt, what are we talking about? KubeVirt is a technology of virtualization on top of Kubernetes. KubeVirt is really powerful, meaning it's also really complex to really understand it. So on this talk, what we will do is just to have a look on the KubeVirt top level API objects. We'll see what they are and how they can help us to actually make more easy or more integrated some VMs with Harvester. The Windows VM optimization. Well, here in this case, when we speak about Windows, there's a lot of settings that might not be the same as if you run, let's say, a Linux VM. In this case, we will see which default options can be changed, and so we can actually have a better experience with Windows on top of KubeVirt and therefore HarvesterHCI. Finally, everything will be running on Kubernetes. So different features will be actually being leveraged directly from the Kubernetes core APIs. So with this introduction already done and how, let's say, how everything integrated together. Let's see now how it works. So here I'm on a page of management of the Harvester cluster that I have installed. And first thing off, you can see that I have several VMs here already created. Two of them are not running, and my Windows VM is running here. First, let's have a look at the configuration here if we click on Edit Config. And this configuration is actually exactly the same as when you will create your own VMs on Harvester. So first you will give it a name, and then in the Basics tab, you will give it a CPU and memory. This is quite easy. This is quite like normal and standard for every virtualization uh, technology. Then on the second tab, here we can see that we have volumes. These volumes actually will be created as also volumes in Kubernetes behind the scenes and will be bound together with the VM. In this case, we have a CD-ROM disk that is created with the ISO for Windows 2022, which is Windows Server. Then we have a root disk. As you can see, it's quite small for now, but that's on purpose. It's 64 gigabits. And also here, you can see that if the CD-ROM disk has the SATA bus configured, here for the disk, we will use the preferred virt.io driver. Finally, because Windows works with virt.io but by default does not have the virt.io drivers, then we have also another CD-ROM in this case with the virt.io drivers. Back to the menus. Here we can see that we are using the default management network from Harvester. It's provided for us and created behind the scenes for us also, so we can just simply leverage it. For production loads, it's strongly advised that you create your own network on a different VLAN than a management network. So you have a management network and a VLAN network that are separated. The node scheduling, in case your HarvesterHCI is on multi-node configuration, then here you can also set where you want to have the node scheduling. Now, these terms, as you can see, are more and more connected with Kubernetes, and that's what Harvester now is doing. Harvester is building on top of Kubernetes, as I said, and KubeVirt at the same time. But then we can leverage definitively what Kubernetes has been doing since years. And here, the node scheduling is one of the features. Finally, the access credentials. We will not use them here, but they are really useful, for example, when you are using SSH on Linux machines. The last tab just reminds us like which OS type it is, which type of machine based on KubeVirt machines types we want to use, and if we want to pass some cloud config. Again, this cloud config and network data are really more used when you are creating Linux machines, but some work is being done as we speak for the Windows side. And here we can click on cancel. Normally you will click on save and it will create now your VM. Once your VM is created, you can start it, because this one is already started, I will not do it, but you can start it from the menu. And what Harvester did really intelligently was to implement directly a console. Here we will open the web VNC, for example. The web VNC will open directly, as you can see, a session against your VM. And here to press Ctrl Alt Delete, of course we cannot. We have here the option, and one of them will be Ctrl Alt Delete. So by pressing here, then I will be able to give my password and then enter. Here, as you can see, I'm on my session. So let's just close the Windows update. Like I said, this is a Windows Server 2022 standard. It's an evaluation copy. I didn't pass anything. It's just for the demo sake. But you will want to here have your licensed Windows servers. Now, these all seem pretty integrated, but nothing showed us that it was different from a normal VM. And that's because if we can come here on the task manager, for example, on this page, I went directly to performance. And as you can see, the virtualization is enabled, meaning I will have nested virtualization on my Windows VM on top of KubeVirt. So this one is already like pretty useful, especially if you want to run maybe some Hyper-V workloads. So it will be maybe good to do performance testing beforehand, but at least the virtualization can be enabled. Another point that this VM is running on top of KubeVirt and on, let's say, how Windows should be run, we can see that the BIOS mode here is UEFI, and we have also the SecureBoot, meaning it will allow you to enable some of the features from Windows that require these two options to be set to true. So everything on the VM is done and optimized that Windows feels like Windows, but on top of Kubernetes. Okay, as a last small demo that I want to show you and how Harvester is actually powerful, remember I mentioned the operational easiness, let's say, or the operational work that could be make more easy. One of them, especially when you are working with VMs, is to allow new storage to be added to the VM. So here, thanks to KubeVirt, Kubernetes, and Windows, we can have something that we call hot plug volumes. And by going to the menu, so I'm back to the page of Harvester, I click on the three buttons here, and then here you can see add volume. So it will ask me a name. So I will put like SUSECON 2022. And the volume, as you can see, is not created yet. So to do that, I will have to go to volumes, create a new volume. I will give it the name SUSECON again, 2022. It's a new volume, and let's give it 100 gigabytes, and I will click create. This should take just a few seconds. As you can see, it's already ready. So it's pretty fast, actually. And now if I'm come back to my virtual machines, and let me add again the volume. In this case, again, I will again set to SUSECON 2022. And this time you can see that the volume is available to be added. So I can simply add it, click apply, and now it says that the volume is mounted. So let's get back to my volumes here. And if I come to the page of disk management on Windows, and I scroll down, here it didn't add anything, but then now you can see it's refreshed, and now my disk is appearing. So I can initialize the disk, I can keep it as GPT, and then from here I can create a new volume with the size. I can ask which letter it is. Let's pick S for SUSECON, for example. And then I know it's my SUSECON, SUSECON 2022 volume with a quick format. And as you can see, I could add the disk without rebooting any VM, and my disk is now available. So let me see, it's here. And if I create a text document, welcome to SUSECON SUSECON 2022. It's okay. The disk has been mounted and is fully operational. As you could see, this was really fast and I could mount everything as in a hot volume, right? So the demo is now done. Let's go back to the presentation. So the demo was all about Windows VMs and how it could be working on top of HarvesterHCI, how HarvesterHCI is providing us with some features to allow us to make Windows feel like Windows. And here, let's see how we could make it happen actually along the year. So the first thing was that the options by default were not there when we created Harvester HCI. And since then, there's a lot that has been actually added. And thanks to your feedback, the community, the users that are already using Harvester HCI, we can really make it even better and make it more seamless. We can have like the UI that of Harvester that is really conforming and being useful from your point of view to create these VMs and manage them. One of the different features that we changed was that the run strategy here that you can see in violet, it's rerun on failure. Initially, we were running VMs as the run spec, and these ones, unfortunately, as I said at the very beginning, it's running on top of Kubernetes. So anytime or every time that we would like to rerun or to stop, sorry, we wanted to stop the VMs on Kubernetes, then Kubernetes will see the pod because the VM is running on a pod. So you will see the pod being crashed or being deleted. And so it will automatically recreate it. KubeVirt and Kubernetes by default implemented these run strategies. And these allow us actually now to, when we will stop the VM from the VM directly, not clicking the stop button from Harvester management console, it will actually stop also the VM. This seems simple or wanted, but by default it was not the case. So we could implement that. Another point here, as you can see in green, was all the CPU features. This one is more related to KubeVirt directly, not really Harvester. And KubeVirt on this one really allow us to load CPU features from KeyEmu, the virtualization technology that it's using behind the scenes, and actually load them into our VMs. So in this case, we can see that we could enable the virtualization, which is this one here, and also that the hypervisor will not be seen by the Windows VM, in which case Windows thinks that it's a bare metal machine and then can also run other hypervisors on top of it, like Hyper-V in this case. This feature here is really, really useful, especially if you need workloads that need this nested virtualization. Another feature is also the firmware that allowed us to have the bootloader enabled and the SecureBoot set to true. All these features are available as we speak from KubeVirt, and Harvester is simply leveraging it. So now we saw that we were using the web console, right? But the problem is that the web console has a tiny resolution, cannot be changed, is a web page, can be closed, and so on. So when we are dealing with Windows VMs, the de facto or the standard that we wanted to apply will be to use a remote desktop. Now, remember, we are running Windows VMs on top of Kubernetes. And here, KubeVirt and Kubernetes actually help us to create something really easy to actually configure. As you can see here, there's a YAML description of a node port service. This node port service will help us to have always the same IP, or the DNS name of your KubeVirt installation, and then somehow it will create a reroute or an ingress towards the VM that we want. In this case here, we can see that the node port is the 30,002, and then a port that is on KubeVirt site, can be random. In this case, is 27,017. Which protocol of the port we want, and what is the target port inside the VM. So we have three ports. We have the public port, the, let's say, KubeVirt or Kubernetes port, and then we have finally the target port, which is the VM port. Thanks to this, we can actually connect directly to the VM using remote desktop. Here, I will just show it to you. As you can see, so instead of a DNS name here, I have the IP of my HarvesterHCI server running. And then here I have the port. And when I will click on it, I will connect. And you can see that we are back to our VM. And to prove it, we can see here the disk that we were seeing. And now, instead of a simple web VNC that is really small, I have a full screen, full HD in this case, on my screen resolution, and I can work based on remote desktop also. Meaning I will be able to copy paste, for example, text outside to inside the VM. Let us go back to the presentation. And this one is really, this option here, or this example here, is fully working. So we saw all that. We saw how to run Windows VM on KubeVirt thanks to HarvesterHCI. Of course, there was some lessons learned. So the main ones was that, as I said before, HarvesterHCI is evolving at a rapid pace. Is already production ready, so the V1 is already out there. Actually, we are in V102, and its development is really bringing, let's say, new features into it. And these features are, while are developed by SUSE directly, HarvesterHCI is an open source project. So your feedback, your contributions are more than welcome. Also, KubeVirt, I didn't know really much about it. I knew the name, but while using it through HarvesterHCI, I could see that KubeVirt is a really powerful tool and allow us to run almost native VMs feeling, let's say, like VMware or Hyper-V on top of Kubernetes. So the technology itself is also an open source project and is also being developed in a very rapid pace, which is really good. Now, when we are implementing these VMs or the configurations on KubeVirt, especially if you want to really detail your configuration, the documentation trail might be quite massive. Okay, there's no one source of truth, yet. You will need to understand what are virtualizations, key emu virtualization, what are the tags, the features, the CPU options, and so on. So in this case, the previous slides I could see when we saw the features, this was all about KubeVirt and the top level API objects. It's a first step into it, but we will need to really understand it. And then finally, thanks to Harvester, KubeVirt, and Kubernetes, there's additional features that are already available but might be more complex to implement, such as GPU, live migration. The hotplux volumes, we already saw it, and Harvester already pre-implemented for us. But if we want live migration, Harvester has it. So give it a try if you have several nodes where you can install Harvester, make it a cluster, and see how the live migration can work. Another one, of course, is GPU based VMs for any GPU intensive workload. And finally, in the future, potentially, we might have also CPU emulation, such as our machines on x86 or vice versa. Here is a list of resources that I used during this presentation and also during all the discovery that I made for implementing HarvesterHCI using KubeVirt and Kubernetes itself. I thank you for following this session, and if you have any questions, I will be available in the chat, and I hope you enjoyed, and thank you for joining us during SUSECON Digital 2022.